Sleep Mode 1 uses the sensor feedback to directly control the drive's output frequency. Sleep Mode watches that value, and when it reaches a limit you set, it turns the output frequency to the motor off. We'll use this water tank demo that we set up and configured in this video. These are the basic setup parameters that we used in that video. For Sleep Mode 1, we have the ultrasonic sensor set to provide 20 milliamps down here and 4 milliamps up here. So the sensor is telling us how empty the tank is, not how full it is. The fuller the tank gets, the smaller the sensor signal will be. These are the Sleep Mode parameters. This tells Sleep Mode to watch the frequency command to make its decisions. It can also look directly at the process variable. This one is used for PID, which we aren't using here, so we can ignore it. This is the drive frequency where we want to turn the motor off or go to sleep. And this is the drive frequency where we want the motor to wake up and start pumping again. I'm going to set these parameters without explanation because it'll be easier to understand them after we run the demo. Let's enable GS4 scope function and adjust the potentiometers to the sleep level and the wake up level. Now you don't have to do this in your application. I'm just doing it as a convenience for this video. I also added a float in the water tank with some LEDs on it to make it easier for you to see the water level rise and fall. Well, given that setup and an empty tank, the sensor is sending a large signal back to the drive. So when I hit run on the drive, the motor starts up fast because the sensor is controlling the drive speed. As the water level rises, the sensor signal gets smaller and smaller, and the motor runs slower and slower. Eventually, it gets to the sleep level we set in parameter 729, and Sleep Mode disconnects the frequency command from the output, and the motor stops pumping. Perfect. I'm going to open this valve to simulate demand on the tank. As the water level falls away from the sensor signal gets larger and larger until it passes the wake-up level we set in parameter 730, where the motor turns back on again and repeats the cycle endlessly. That's Sleep Mode in a nutshell. It automatically controls the tank filling process with nothing but an analog input. We can also delay the wake-up and sleep transitions. I put 2 seconds in for each one. Now when we run the test, I'll speed up the video here, we see sleep waits 2 seconds after hitting the wake-up level to turn the motor on, and it waits 2 seconds after hitting the sleep level to turn the motor off. So the sensor signal had to be past the threshold and stay there for 2 seconds before sleep would activate. That's a great way to get rid of intermittent threshold crossing due to noise, for example. Well, this looks okay, but there are 2 big problems with this. First, since the sensor returns smaller and smaller values as the tank fills, the drive frequency will get smaller and smaller, and the motor will turn slower and slower. All of which means it will take a long time to fill the tank. Wouldn't it be better if the motor could just quickly fill the tank at full speed all the way up and save this time? The second issue is, again, since the motor is going slower and slower as the tank fills, eventually the motor speed will get to the point where the centrifugal pump is spinning too slow to move the water. And it'll sit there and cavitate, which means it's not filling the tank, it's heating up the water, it's reducing the service life of the motor, it's reducing the service life of the pump, it's wasting your electricity, and it's wasting your money. That's why I set the sleep level at 20 Hz. Anything below that, and this pump stops working. But since the sensor is controlling the drive speed, that means we can't fill the tank past this level. The solution is simple. We just raise the minimum drive speed to a larger value, and that keeps the motor going fast regardless of the command frequency. I'll set it to 90% of the full 60 Hz, which is 54 Hz. Well, that takes care of speeding up the tank filling operation because we're forcing the motor to go fast most of the time. And since the new min motor speed is nowhere near cavitation, we can also set the sleep level to whatever level we want. I'll set that to 5%, which is 3 Hz. And that takes care of issue number 2, filling the tank to whatever level we want. Let's move our sleep level cursor down to that new 3% level so we can see if the motor turns off at the right time. So now as the water level rises and the motor starts to slow down because the sensor value is getting smaller, when it hits the high minimum speed we just set, the motor just stays at that high minimum speed even though the command frequency set by the sensor is still falling. When the sensor hits the new sleep level of 3 Hz, the drive shuts off after the 2-second delay. So now the motor is filling the tank quickly independent of the sensor value, and it's filling to whatever level we specify. Perfect. The bottom line is Sleep Mode watches the frequency command, which in this demo is being driven by the sensor, and decides when to let it through to the motor. And we added the trick of adjusting the min drive frequency to a high value, and we were good to go. Now, is there a way to do this without tricking the drive's min frequency? Well, yeah, there is. You just tell the drive to use PID as the frequency reference. PID's job is to get a process to whatever level you specify as quickly and efficiently as possible, right? Well, that's exactly what we want. We show you how to use PID to do this in the other videos in this series. Click here to learn more about the GS4 drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to Automation Direct's YouTube channel so you'll be notified when we publish new videos.